Hi Cutie Pie, I am Athea, A for short, your tutor for today's lesson. In this video, we'll be discussing affine cipher. Just to recap, the previous cipher that we talked about is substitution, if you can remember. But before we define what affine cipher is, let me introduce to you modular arithmetic. In modular arithmetic, we make use of z sub 26 or the integers mod 26, which consists of the numbers from 0 to 25. This means that after every 25 numbers, we go back to 0. For instance, 0 is equal to 0, 1 is equal to 1, 2 is equal to 2, and so on until we reach 25 is equal to 25. However, once we reach the number after 25, which is 26, we go back to 0, and so on. In affine cipher, a working modulo or the length of the alphabet used is involved, so we'll learn how to get this first. The very main goal is to get the remainder. These are the steps that we need to do, or the operations that we have to use. So for example, we have 56. To solve for the remainder, we first divide 56 by 26, and then we'll get 2.15. Secondly, we multiply the quotient, only the whole number, which is 2, by 26, getting a product of 52. We then subtract 52 from 56, getting the remainder 4. So that would be the answer. Pause this video and try to answer the rest of the given questions below. Okay, let's solve the first one together now. Step 1. We divide. So that's 21,634 divided by 26 is equal to 832. Step 2. 832 times 26, that would be 21,632. Now we subtract 21,634 minus 21,632, we get 4. That would be 4 as well. Alright, let me erase this first. Now, in getting a negative number, the remainder of a negative number, we only subtract its absolute value from 26. So what is the absolute value of negative 6? That's just 6. For example, if we have negative 51, the absolute value is 51. Okay. Back to this. That would only be 26 minus 6 is 20. And that's the answer. But what if we have a negative number that's more than our modulo, which is 26? In solving negative numbers whose absolute value is greater than 26, we first have to multiply 26 by a number which can result in a product more than the absolute value of the negative number. So let's try to. 26 times 2 is 52. Now 52 is greater than 45, right? So that's feasible now. Now we will subtract 52 minus 45, that's 7. And the answer is 7. Lastly, the answer to this last one is just 0. Why? Following the steps we have 26 divided by 26, that's just 1. 1 times 26, that's 26. And lastly, 26 minus 26, that's 0. So the answer is 0. I hope that's clear. Now let's move on to affine ciphers. But before that, we have here our A to Z and 0 to 25 table. While this is our A and A inversed. These are like formulas that you can check if you are solving an affine cipher. Okay. In affine cipher, we make use of this modulo and the formula in encryption here and decryption. So in encryption, we have AX plus B mod 26, while in decryption, we have A inverse multiplied by Y minus B. This is our key. So for example, if we have our key 7 and 22, we would just substitute the numbers to get the encryption and decryption. So that's 7x plus 22 mod 26 for encryption and 15. Why? Because 15 is our inverse for 7. So 15 multiplied by y minus 22. Now let's apply it with an example. Let's encrypt the text cute, C-U-T-E, with key values of, let's say, 3 and 8. First thing that we have to do is find x, or the numerical equivalence of each letter. So we will use this table. For C, you just find and know that 2 is its numerical equivalent, so that's 2. For U, we get 20. For T, we get 19. And for E, we get 4. Secondly, we'll apply the formula and substitute the given values. So starting with C, we would get the encryption of 2 is equal to 3. That's from here, our key, multiplied by 2 plus 8 mod 26. So the answer would be 14 mod 26. And 14 mod 26 is just 14. Doing the same with the rest, we would get the following. Now, we just have to get the letter equivalents of the remainders. Doing that, we'll get the encrypted message of O, because O is 14. Q is 16. N, because N is 13. And U, because it is here, 20. Here's a pic of how it's done the other way around, or in decrypting. take note, most importantly, in the difference of the formulas. While encryption requires A here, in decryption, we need the inverse of A. So the inverse of 3 is 9. We can check that here. This is 3 and this is the inverse of 3, which is 9. Also, the parenthesis placed, unlike here, this would be placed here, meaning that we should compute this before multiplying. And we're done. Easy peasy. That's a wrap. See you in the next video.